In fact, you already talked about one of my slides, so but again, thank you. So hello everyone, my name is Patrick. I'm a data scientist in Cloudflare, and today I'm going to introduce you Destination Nerve Data Lake, one of the three main components of Destination Nerve. Last year in Tartu, I had a similar presentation, but it was different situation because DestinE was launched like 1 week before last FOSS4GE. Now it's 1 year, so 1 year ago it was more like we hope it works. Now it really works, and we have some insights, of course, some problems which were of course resolved. So again, about this destination Earth thing. So it is a flagship initiative of European Commission, which aims to develop digital replica of the Earth. In fact, several replicas of the Earth dedicated to some specific areas. Nowadays, we have two digital twins. The first one is about climate, ClimateDT, and the second one is about weather. The weather, it is ExtremeDT. In fact, they're both about meteorological stuff, but they provide some different types of data. So Destination Earth is built of three main components. The first one is core service platform, DESP core service platform, which is developed and managed by ESA, European Space Agency, and this is the front of our of all initiatives. So if you want to start your journey with DestinE, there is no other way. You have to visit DestinE portal DESP. On the other end, there is a digital twin engine managed by ECMWF, which is responsible for calculation of on digital twins, producing data, and so on. And behind that, there is data lake, which is some kind of backend environment which provides data and tools to handle with this data. Okay, so what the data lake is? Data lake, beside its services, data, and so on, it is also infrastructure. Maybe even at first it is infrastructure. And what makes it exceptional? This is fact that this is a distributed infrastructure, 5 clouds in that very moment, which are located in different places in Europe. 3 of them are located just next to the HPCs in Lumi, Caiani, Leonardo Bologna, and Mare Nostrum, Barcelona. And when I'm speaking about they are next to HPCs, it's like they are in the same, maybe not in the same building, but in the same data center connected with the fiber. It was done due to reduce latency because outputs of digital twins are huge. It's massive volume of data. It's like terabytes per day, petabytes per year. Yeah, terabytes per day. There are also 2 other clouds, so-called data bridges. All of them are called data bridges, which are cloud on the edges. Other 2, Cloudflare data center and EUMETSAT data center, located in Warsaw and Darmstadt, respectively. They are located just next to the places where the other data is stored. In case of Cloudflare data center, it is store of Copernicus data, Sentinel missions. In case of EUMETSAT data center in Darmstadt, this is the place where Meteosat, METOP data is stored. So this is our infrastructure. I told you a little about these digital twins. So why we should do that? Yeah, we have some other global models, global data sets about climate. So this is the comparison with, let's say, last, but of course still working model, CMIP6, which spatial resolution is like 80 kilometers, I remember. In case of ClimateDT is 5 kilometers. So the progress is huge. Of course, volume is also bigger. And it is even better depicted when we get the local scale. This is Poland, and in the case of this, let's say, previous model, it was like 8-10 pixels within Poland. In the case of ClimateDT, it's thousands of them. And this is the comparison with ERA5 data, total precipitation in the case of ExtremeDT, it is even possible to notice some storm cells, yeah, which in fact was not possible. I don't want to say that it is better, yeah, because Era 5 has legacy, for example, and it is used by many entities. But this data provided, I like to depict differences, yeah, and this, especially these things about spatial resolution. Okay, coming back to data lake. It is built with two types of services: data access and discovery, which is HDA, harmonized data access, and other services which are available on request, so-called edge services. Of course, I'm going to describe all of them. And let's start with harmonized data access, HDA. So HDA. It's a tool to discover and access data from various data providers. Um, Now it's available to get an access to around 200 collections, of course, including digital twin collections. And it is possible using one set of credentials and one API based on Stack. So on user perspective, everything is transparent. You don't have to be logged in, registered on, I don't know, 6, 8 sources, data providers, websites in order to get an access to that. One credentials, one API to get an access to digital twins, to Copernicus services, to Sentinel data, to Metop data, and so on. Yeah, and this is due to federation. There is this is a federation tool also for identity access management. And how you can access it? So firstly, of course, on your local environment, each user of DestinE is granted by default with an access to HDA, so you don't have to send any request for that. Also, it's available to use it on this edge services, which I'm going to introduce in the next slides. So I mentioned that the journey with DestinE begins on Desp Core Service Platform, and this is the QR code to platform DestinE EU, where you can sign in to find services on the edge. This service is provided by DEDL. You have to navigate to Services tab, then find Data Lake, and then we'll be redirected to the Data Destination Earth EU. Of course, you can just register on DESP and then go to the Data Destination Earth EU as well. But as I mentioned, journey always starts with this DESP site. Okay, so let's start with Edge Services, which is the first service on request. Still, of course, free of charge. Yeah, it is completely free. Only thing you have to do is write like, I don't know, 500 words why you need it. And we start with Stack. Stack with the K at the end. So this is completely something different than Stack catalog. I know it could be confusing. So what the Stack is? Stack is in a big short, is a Jupyter Lab environment which is deployed on all of these 5 data bridges. And it allows you also for creation of Dask clusters, but not only, let's say, within some virtual machine, be limited to 5 CPUs and so on, but it is also possible to deploy your Dask cluster on different size, different location. So let's say you want to analyze this digital twin outputs data. So the best place to deploy your Dask cluster is Lumi or Mare Nostrum. But if you want to do some analysis with Sentinel data in the same script, I don't know. For example, yeah, script is a good word. You can deploy your Dask cluster on Cloudflare on the central side. Again, I just to remind you about this reducing of latency, yeah, and it could be managed from one notebook, one script. It is also possible to connect with this Jupyter Lab environment through SSH. So let's say you don't have to use web browser if you don't want to. This is how it looks like when you choose the proper site. And a few words about Dask. Yeah, so as I said, it allows you for creating remote clusters. Also, it is possible to create in some dashboards to track the progress, track the processor, and so on. Also, the most important thing, which I explained at the last slide, distributed parallel computing on different locations. Stack is also provided with some plugins. The first one is CODAC, which is developed by our colleagues in the consortium CS group. If you don't want to code so much, or if you don't like, you can just I don't know, use this graphic user interface tool, and it prepare code for you. There are also some other plugins, access to object storage. So if you're granted with an access to S3, you can put URL over proper tab, then provide your credentials, and then you can access your S3 storage directly from Stack and put there some results or source data. Oh, there are also, of course, GitHub and Dask plugins as well. So we have platform as a service. Now function as a service, which is Hook. Hook is a list of predefined processors, including calculating LLI, backscattering, coherence, performing atmospheric correction using Cent2Core Maya. And it is, in fact, ready to use. Yeah. Also, users can custom their own hooks and put them into workflows in order to reduce code, save time, etc. Results then are stored on private S3 storage or temporary S3 storage. This temporary S3 storage is available. It's a URL link available like 1 week, as I remember. So quite safety. And you can access Hook through REST API, just as HDA, or through the OpenEO API. Okay, and the last one, another as a service. In this case, it is infrastructure as a service. So I guess the most advanced and the biggest thing within destination of data lake. ILET, which is divided into two components, ILET compute and ILET storage. ILET compute is about providing virtual environment, virtual machines, in fact, cloud, also Kubernetes clusters, to the users. It is built on OpenStack, so open source solution. ILET also provides a list of pre-configured images, also images which are dedicated to dealing with GPU, so you don't have to worry about how to, I don't know, install OS if you want to deal with GPU stuff, because in, there is possible to use file CPU, GPUs, yeah. And about ILET storage, it's just about storage, yeah, to access and manage S3 buckets. Okay, but the question is, why do you need that? Yeah, why so many efforts was done to make a data lake? So the digital twin outputs, as I mentioned, is a massive data. It's a huge amount of data to be processed. I said that it's terabytes of data, but if you want to make some climate analysis, so it's like decades of data, yeah, to be processed. So you need computing power. Of course, it is possible to use Dask in order to make it more efficient on some smaller machines, let's say, but still you need computing power. And this is where this all services comes, yeah. The good example is data cubes. I think it's the best way to deal with such huge amounts of data. So if you want to build and then process this data using data cubes, you need computing power. So this is where the this is where the ILET is. And some examples of outputs analysis using Xcube, also open source solution. I didn't mention about it, but ExtremeDT data is also provided with 4 kilometer resolution. It is a forecast. It is a 4-day forecast with step 1 hour. So you have 96 layers within this data set. Of course, each day it is updated, and this is the case of rainfalls, heavy rainfalls in Spain last year. Not Valencia, it's Malaga. Mm, and with each next forecast, it was closer to the real rainfall. Yeah, still it was underestimated, but it is a generic problem with precipitation, in fact, and convective rain. But again, with each steps, it was closer to the real situation. This is how you can access this S-services. Maybe I will skip it, go to that, because I mentioned that you don't need to write a proposal, something like that. Yeah, that dozens of papers. No, it's just like 500 words, one page of some justification, explanation. Why do you need that? So think about it. How cool is that to have a free GPU? Yeah, of course it's limited, and you have to have a good justification for that. But still, it is possible, and of course free of charge. This is where you can raise this request. Okay, at the very end, I like to encourage you to visit our GitHub page where we provide, I mean, Cloudflare, CS Group, EODC, EUMETSAT as well, a lot of tutorials which are really up to date. After each implementation, each change, we update it, so you can be sure that everything which is on that site, it's really up to date, and there is a lot of tutorials. Starting with HDA, how to download data, also with how to use stack and hook. So, if I lost you in some place of this presentation, if you were bored, this is the quick summary. So, HDA, it's about data access and data discovery. API with 1 credentials, 1 API in order to get an access to 200 collections from different providers. Services on request, stack, it's about visualization, possible to get it via web browser without deploying virtual machine, allows for parallel computation. Hook, save time, less coding, ready to use workflows. And islet, computing power, virtual machines, Kubernetes cluster, near data processing, and S3 to store data. And this is it. Thank you very much. I hope you enjoyed.